Functions like these are called parent functions. So here we are going to consider 5 examples of basic parent functions. We have more than this actually, but we only consider these 5 with their reflections. Okay, so from the first one that we have here, y is equals to x. So it is important for students to understand the domain of function and the range of function. This will definitely help a student to sketch the graph of that particular given function. Alright, so for y is equals to x, so we have to start from the domain. So the domain of this is set of real numbers. So domain is just like a set of inputs and range is set of outputs. Okay, so the range of this particular function is f of x belongs to a real number. So if that is the case, so we have the graph for this given function, something like this. And this is the graph of y is equals to x. What that means is that both x and y have the same value. So when x is positive, y is positive as well, and when x is negative, y is negative. So for the reflection, which is y equals minus x, okay, y equals minus x, so this is y is equals to x. So for y equals minus x, now I can just plot the graph here again. So and the only difference is that we are going to have a line like this. Okay, so this line here is for y equals minus x. Okay, so they both have the same domain and range. That's for the first question. Now for the second function, which is y equals x squared. Y equals x squared. So the domain of this function is set of real numbers. Okay, why the range here is f of x greater than or equals to 0. Now for a quadratic function like this, okay, it is important this x squared can take any different value for x. Okay, and the possible outcomes we can obtain here are numbers greater than or equals to 0. We cannot get negative here. That's the meaning. Irrespective of the value of x, this can never be negative. Okay, so the least value we can get here is 0 for y. The least value of y we can obtain here is 0, and that can only happen when x is equal to 0. So now the range of this now is x is greater than or equals to 0. So for a student to get to sketch the graph of this, of course, quadratic function has parabola shape, okay, which is of this form. Okay, so that is for y equals x squared. All right, so and the other one there we have y equals minus x squared. So minus x squared is just like a reflection of x squared on x-axis. So when x squared reflect on x-axis, then you have minus x squared. So the domain of this domain is also set of real numbers. Why the range here changes? So the range here is f of x less than or equals to 0. So what that means is that for every value of x you put here, you get corresponding value of y to be negative. So you cannot get positive value for y in this case because of the negative you have as a coefficient of x squared. Okay, so now we said this is for x squared. Now for y equals minus x squared, I told you that this will be a reflection on x-axis. So if this parabola now reflect on x-axis, then we have something like this. Okay, we have something like this, and this is for y equals y equals minus x squared. All right, so let's consider the next function. The next function here is absolute value of x. Absolute value of x, number 3. So we start from the domain. As usual, domain of this function is set of real numbers. Okay, set of real numbers, that's the domain. And the range here, remember the definition of absolute value is that absolute value of any number will definitely greater than or equals to 0. Okay, so absolute value gives non-negative results. So what that means is that this is actually greater than or equals to 0 as well. Okay, so y is positive, y is non-negative for every value of x that you put here. So that is the meaning. And the graph of that, for students to sketch that, the parent function for that is like this. So this is the parent function for y equals absolute value of x. Okay, then for its reflection, which is y equals minus absolute value of x, so this actually reflects on x-axis as well. So when that reflects, the domain here is x set of real numbers, and the range is f of x less than or equals to 0. Okay, and now this particular curve, now when that reflects on x-axis, we are going to have this. Okay, we have sorry, it should be something like this. Okay, so and this is for y equals minus absolute value of x, and this is y equals absolute value of x. All right, now the next function, that's square root of x. Square root of x. Okay, so the domain of this, what will be the domain of this? Remember, square roots can only take positive value. Okay, you must not get negative inside square roots. So the moment you have square root of negative, you have undefined for real numbers. Okay, but for complex number, for imaginary number, when you have square root of negative, you have imaginary numbers. Okay, but here, since we are talking about the graph here, we only consider set of real numbers. Okay, so meaning that x can only be positive here, x can only be non-negative rather, and what that means is that the domain of this is greater than or equals to 0. Okay, because when, let's assume we consider value of x that is negative, let's say minus 4, square root of minus 4 cannot give us the number. That is the meaning. Okay, then the range, if the set of inputs is non-negative, okay, so what will now be the set of outputs, which is the range? So the range here is also f of x greater than or equals to 0. So we cannot get negative here. Y can never be negative. That's the meaning. Likewise, x cannot be negative. Okay, so now for you to sketch the graph of square root of x, we make use of the domain. Here we said x is greater than or equals to 0. So this is this place, and y is greater than or equals to 0. That is f of x is greater than or equals to 0. So we must definitely have something like this. So, and that is the graph for square root of x. Okay, so for its reflection, which is y equals minus root x. Okay, the same thing applicable to this domain here. Domain here remains as x greater than or equals to 0. Y range changes here. So range here now is f of x less than or equals to 0. Okay, since square root of x, minus square root of x reflect on x-axis. Okay, so you have the graph, the curve for minus root x now to be something like this. So that is the only difference there. Okay, so something like this. Okay, so this is root x, y this is minus square root of x. Okay, now the last one we are going to consider in this tutorial is y equals to 1 over x, and of course this is rational function. Okay, rational function. So to get this now, we look for domain as usual. We find the domain. Now the domain, this particular function can only be defined for set of real numbers except when x is equals to 0. What that means is that when x is 0 here, when x is 0, we obtain y to be 1 over 0, and this is undefined. Okay, and this is not possible. Okay, so we must not have something like this. Okay, so but if you substitute any other values for x, the function must be defined. That's the meaning, except x to be 0. So now we are not going to use that to define the domain, which implies that the domain of this is set of real numbers, but that particular value must not equal to 0. That is the meaning for that. Okay, so and this x not equals to 0 is what we call asymptotes. Okay, x equals to 0 is the asymptote, and that is the vertical asymptote, and we explain that later in subsequent tutorial. Okay, so we have vertical asymptote, horizontal asymptote, and oblique asymptote, but we are not here for that one. Okay, so now for range of this is f of x belongs to a real number, and this also implies that your f of x cannot be 0. What this means is that you cannot obtain value of y to be 0. There is no such value of x that will make y to be 0. That is the meaning. But you can get any value for y except 0. Okay, so that is the horizontal asymptote here. So to sketch that, remember the two conditions we have there, that x can never be 0, then y can never be 0. What that tells you is that the curve cannot or must not intersect x-axis, then likewise the curve will never intersect y-axis. Okay, so by implication we have something like this. Okay, so this is for the graph of y is equals to 1 over x. Okay, so now for y equals minus 1 over x, the same thing applicable to this. You have same domain and range, but this will actually reflect on x-axis. Okay, so when this reflects, this is for, I think I will need to consider new graph for that. Okay, so this is for y equals minus 1 over x, and the meaning is that when x is negative here, you obtain y to be positive, and when x is positive, y is negative. Unlike the first one, that when x is positive, y must be positive as well, and when x is negative, y must be negative. So these are the graphs of these parent functions we consider here. So we have more than this, but in subsequent tutorial we explain better on the remaining parent functions. Okay, if you are just joining us for the first time, kindly click on the subscription bell so that you'll be notified whenever I release another video. Thank you, and don't forget to drop your comments. Okay.